Counters. Today my topic is the counters. A comprehensive overview of a counters. The types of operations and applications. And classification of counters. The types of counters. Up, down, up, and down. Applications and IC elements. A 0, 1. A special counters, a decade ring, Johnson, advantages, limits, and conclusion. What is digital counters? Definition. A digital counter is a fundamental sequential logic circuit designed to store and count the number of times a specific event of a process occurs, typically in a response to a clock signal. Core properties: timing synchronized with the clock signals, sequencing the state transitions in a specific order. Counting representations occurs in binary or BCD formats. Counter constructions. Constructions is a flip-flop of basic memory elements. Counts plus representing a count is a binary or BCD. This showing symbols or counting directions is up counter is and down counter is up and down counters. Opposites up and down counters. Classification of counters. Digital counters are categorized based on how our internal flip-flops or clock, which significantly impact their perform characteristics. Asynchronous counters, ripple factors, external clock, sequential cooking. Only the first flip-flops receives the external clock pulse. Ripples effect. The change rate propagates through the counter's lower speed. Cumulative propagations, a delay limits maximum frequency. Synchronous counters is the difference. This is ripple counters and this is parallel counters. A simultaneous is coupling all flip-flops or share a common clock signal. This another one is low speed, this one is higher speed. The parallel cooking implements a cumulative propagation delay. Compressors requires additional combinational logic for controls. Asynchronous ripple counter definition. Synchronous counters as allocanas a ripple counter characteristics by a sequential clocking mechanism where flip-flops are not triggered simultaneously. Key characteristics: sequential cooking only 01 or 001100 is the first flip-flop that receives the external clock pulse. Ripple effect: the change of state propagates through the counter one flip-flop at a time. Simplicity: generate the simplifier to design the construct due to the straightforward cascade arrangement, low speed, cumulative propagation delay, limits, maximum propagation frequency. This is ripple counter operations. The output each of the preceding flip-flops services as the clock input for the next flip-flop in the chain. Applications is the time, event counters, and digital codes. Ripple counter operations and limits. Operations limits. A sequential cooking only first flip flops receives external cumulative propagations delay cumulative through the clock the chain and output each flip flop service clock for the next momentarily unstable output is a clock ripples through the flip chain flop. Ripples affect a state change propagate through the counter one. A timing mitigates limits a maximum property frequency a 3-bit ripple counters and clock Q0 or Q1. Uh, this is cumulative propagations delay. Sequential trigger makes a ripple counters unstable for high speed applications and Q0 is left side and Q2 is right side and middle one is Q1. These are a triple counter 3-bit triple counters. Synchronous counters working a principal synchronous counters all the flip-flops are connected into a common block signal ensuring that the state change occurs simultaneously. All flip-flops change at a time at a same time. Use combinational logical circuits inputs. Circuit implementations. There are 4 bits, 2 bits, 2 bits or 3 bits or 4 bits. A number of bits. 4 bits. This is 4 bits synchronous of counter using JK flip flops. Q always to each clock pulse Q toggles only Q0 is high. Q2 is when both Q0 and Q1 high. You can show in the diagram. These are 4-bit synchronous. Is Q0, Q1 and Q2 and Q3. These are applied NAND gates. Key characteristics high speed and simultaneous changes. Synchronous counters advantage high speed operations, elemental cumulative delays, more relay operations. Perform clocking eliminates cumulative propagations and delay arrowing operations at much higher frequency. Eliminated cumulative delays, no ripple effect is minimal states occur. Changes occur simultaneously, ensure stable outputs, a more reliable operations. Concurrent state changes provide predicates and reliable performance is high-speed digital systems. Synchronous was asynchronous. Q0 is asynchronous. Q1, Q2 non-asynchronous. All flip-flops change state simultaneously. Synchronous is a higher speed, asynchronous is lower speed. Synchronous is simultaneously, asynchronous is cumulatively. Synchronous is reliability higher, asynchronous is lower. Have types of counters up, down, up and down. Up counters is increment is store value by 1 each clock pulse. Counting is ascending sequence. A down counter is a decrement store value by one each clock pulse. A counter is a decrease sequential up and down combination functions of the both down with control input determined counting directions. This is up one counter, this is down one counter, this is bidirectional. Yeah, special counters, yeah, ticket counter, yeah, definition, yeah, ticket counter is also known as the MOD is 10 counter or BCD counter is designed here counted through 10 distinct states 0 to 9 and decimals. Rest 0 AK frequency, council digits, decimals, dig- decimal digits and 0 to 9, 10. The rest of the after the reaching 9, you provide a binary representation so for each decimal digit BCD. Applications, digital clocks, frequency matters, display systems, digital systems. Decade counter sequence 1, 2, 3 up to 9. Counters is 0 to 1009 and decimals 0 to 9. BCD representations and up to 0 to 9 decimals. Special counters is the decade counters. Special counters, ring on Johnson, ring counters, special sequential circuit formed by connecting the outputs of the last flip-flop, shift register back to input first flip-flop creation is circular arrangements. Characteristics typically initialized with a signal I beta circulations through the flip-flop, while all other flip-flops hold me opposite state, and n flip-flops is ring counters an unique states. Amount and counters is a sequencing the control systems on hot ports. 4 bits. Johnson counter, a modify of the ring counters varies the inverter out of output of the flip feedback to the input output. First flip flop characteristics 2n unique states of the n flip flops counter not 2n counters similar to a code sequence when only a bit characteristics at a time change. Specifically waveforms is usually times circuits applications. Waveforms control system frequency designs are 4 bits. Application standard application digital clocks count seconds minutes or hours display the time. Frequency counters measure signals frequency by counting pulse over time. Time generating precise the time delay for the event control. Event counters count product assembly lines events and memory addressing a step through memory allocation is sequentially state machine control flow in the embedded systems. Technical emerging technically emerging applications data acquisitions tracking simple intervals on buffers frequency divides sets is bilaterals along two digital conversions IoT devices data logic with real-time monitoring automation process and control and management defense system counters enhancements aerial vehicle tech advantage and limits synchronous counters simplified designs straightforward cascade arrangements lower components counters resulting in lower cost limits limits is propagation delay, effective maximum operations frequency, sequential technology induce the limiting is at a high speed, a synchronous counters advantage, a faster operation, is simulation, fast state change, and new cumulative programs, a delay or perfect limitations. More complex design requires additional logic gates, high cost due to the increased component count. Choose between synchronous counters involves balancing simplify the performance requirements. A summary and conclusions. A key takes counters fundamental sequential logical circuits using flip-flops, store count events, a response to clock signals, a synchronous counter offer is simplified, but they suffer from the propagation delay with while synchronous counters provide faster, more realized operations. Various counters this types of up down up and down special service specific applications in digital systems. Countries find essential applications in digital clocks, frequency measurements, industry automation, advanced control systems. Control types up or down, up and or down indicates rings, Johnson application, digital clocks, frequency counters, timer events, and counters are fundamental building blocks. Digital electronics is essential for event timing process and generating the sequence in modern technology. Thank you.